All right, guys. I said there's a warm-up. There's kind of not a warm-up. We're just jumping in. So let me draw on here sine of x. So draw. Are we okay? We're almost there. Hopefully we know what sine looks like. Hopefully that didn't leave your brains. All right, guys, let's try to sketch the derivative. How do we do that? Try to draw the derivative for me, and then I'll put it up here in a second. Okay, guys, so remember where your original has a maximum. That's where your derivative has a 0. It has a minimum, it has a 0, so I know those 2 points. The first stretch of my sine curve is increasing up to the maximum, so I know the derivative has to be above the x-axis. Then it's decreasing all the way to there, and then it's increasing again. Draw this left side very well, but what graph does that look like? Cosine. So the derivative of sine is cosine. Let's find, sorry guys, I'm bored with normal colors. Let's find the second derivative. Try to sketch that for me. Draw this one better. So if I go from, I'm just going to look at the pink graph and take the derivative of that. So wherever it has a max or min, my derivative would have a 0. So it's got the same zeros as the original sine curve, but it's not going to follow sine because instead of increasing, what is the pink graph doing at the beginning there? Decreasing. So this whole section needs to be below the x-axis. And then it starts increasing, so we have to be above the x-axis. So what is that equation? Negative sine. Okay. All right, so we're actually going to go through all the different trig derivatives, not finding them graphically. I'm just going to tell you what the rest of them are. We can find them by taking the derivative of different things, but we're just going to go ahead and list all 6 of them. So first, all right, slightly different notation here. D dx of sine of x. Okay, that's telling you to take the derivative of this little term here with respect to x. There's no y, like this isn't an equation, so that's why I don't have the full dy dx. Like, I'm just telling you take the derivative of this piece that I've given you. Okay, so that's why it looks different. So derivative of sine we know is cosine. D dx of cosine we know is negative sine. All right, derivative of tangent. And we'll prove this one algebraically. It is secant squared. That's what I was saying. This isn't an equation. It's not a y equals, or there is no y involved in this. So it's just saying take the derivative of this piece with respect to x. We don't have a y to deal with. All right, d dx of cosecant. That is negative cosecant times cotangent. That would not be a fun one to find graphically. D dx of secant. Secant of x times tangent of x. And your last one, derivative of cotangent, is negative cosecant squared. Yes, you must know those. Okay. Yeah, for the cosecant, think of all the cos are together. The secant, they're not. Those two are weird to memorize. All right, let's try one. Let's find d dx of tangent. Now we know what this is supposed to equal, but let's show like why it equals that. So how can I rewrite tangent? Sine over cosine. So d dx of sine of x over cosine of x. Okay. So what rule am I going to have to use? Quotient rule, yes. All right. So denominator times the derivative of the numerator. Well, what is the derivative of sine? Cosine. Yeah, look at your little list there. I don't expect you to have those memorized yet. Minus numerator times the derivative of the denominator. What's the derivative of cosine? Negative sine all over cosine squared. All right, so I've got cosine squared. And then do you see how it's plus sine squared? All over cosine squared. So what happens? Yeah, cosine squared plus sine squared is 1, right? So yes, you do have to remember that from your trig days. So I have 1 over cosine squared, and what is 1 over cosine squared? Yep. Now, in a problem, if you see tangent and you need to take the derivative, just say it's secant squared. You don't have to like go through and prove that every time. That's just why it is secant squared. Okay. So we could find all 6 derivatives that way. We are not going to. We're just going to use them. Okay, let's try. All right, we're going back to having an actual equation now. So we're going to find dy dx. Given that y is equal to cosine of 5x. Okay. We have to use chain rule when we do derivatives of our trig functions. So let's make sure we're good with that. So dy dx equals, so start on the outside. So what's the derivative of cosine? Negative sine, okay. Leave the inside alone, so of 5x. But then what do I need to multiply all of this by? The derivative of the inside, so the derivative of 5x, which is just 5. So take all of this times 5. So you would just write dy dx is equal to negative 5 sine of 5x. Does that make sense with the chain rule there? Work outside in. Stop for a second. We okay? All right, y is equal to sine of 3x squared. You guys try this one. All right, guys, let's see how we did. Okay, so first, what is the derivative of sine? Cosine. So I'm going to have cosine, leave the inside alone, 3x squared. And then what do I need to multiply that by? 6x, yep. So that's it. Your dy dx is 6x cosine of 3x squared. Okay. Not too bad, right? Okay, y equals, same directions, find dy dx. Y equals 3x cubed times the sine of 2x. What's different this time? Yeah, there's a product rule, right? Because do you see 3x cubed times sine of 2x? So try doing this one with the product rule. Mm-hmm. Yep, because you need that 2 from inside. That's where I think that's always tricky when you're using like product or quotient and chain rule to like remember every piece of the chain rule. It's easy to forget that last derivative. Okay, guys, let's take a look. All right, so product rule, I'm going to do sine of 2x times the derivative of that first piece. So that would be times 9x squared plus 3x cubed. Okay, then times the derivative of sine of 2x. So what's the derivative of sine? So I've got cosine of 2x. And then what's the derivative of 2x? 2. So the final answer is 9x squared times sine of 2x plus 6x cubed times cosine of 2x. Yay? Nay? We getting there? Okay. We have 7 examples today, guys, so not too much left. Okay, I'm going to give you y is equal to 2 sine of x plus 3 cosine of x. And we are going to find y plus y double prime. Like, add them together. It's a weird question, I know.
No, it would go to 2 cosine of x plus 0. Oh, yeah.
All right, guys, what'd you get when you added them together? 0 is correct. Let's make sure we got it. All right, 2 sine of x is going to become 2 cosine of x. 3 cosine x is going to become negative 3 sine of x. We good on first derivative? Second derivative, so that's going to be negative 2 sine of x minus 3 cosine of x. So then when I add these two together, you just get 0, okay? It's a weird question, I know. You're just finding distance. All right, let's try again. Back to find dy dx for me. Your y is equal to sine cubed of 2x to the 4th. Okay. What this really means is the sine of 2x to the 4th, all of that cubed. That's what that exponent in there, right? That's what it means. So lots of chain rule fun for you on this one. Give it a try. Start going through it. So you've got to do chain rule. Start on the outside and work your way in. So we would have 3. Leave the inside alone. So sine of 2x to the fourth. All of that squared. Okay, then start working your way in. What's the derivative of sine? Cosine, so it would be cosine of, still leave the inside of that one alone, 2x to the fourth. Then times, what's the derivative of the inside piece? X cubed. So simplifying it just a little, 3 times 8, so I'd have 24 x cubed. And then you could go back to writing this like sine squared of 2x to the fourth times cosine of 2x to the fourth. Okay. Does that make sense? Did I lose anybody in the different steps of that chain? Yeah.
Why does it say side?
Why does it stay sine?
Yeah.
Like at the beginning. So remember when you start on the outside and work your way in. I'm starting with this.
Oh, is it like chain rule like 3 times?
Yes.
Oh,
Yes. Double chain rule. Bonus chain rule. Just what we all want. All right, guys. One more example. Y equals 4 cosine of x over 6. We are going to find the second derivative this time. Okay? I'll give you a minute to try. The final answer is actually fairly simple. It's not like a big multi-piece answer. All right, so your first derivative, you should get -4, not cosine, sorry guys. Sine of x over 6, and then times 1/6. So I can simplify that a little bit. -4 times 1/6, that'd be -2/3. Sine of x over 6. So then second derivative, negative 2/3 times cosine of x over 6. And then again times 1/6. So when you simplify that, you get negative 1/9 cosine of x over 6. How'd we do, guys? Anybody questions on that one? Let's stop for a second here and see how we're doing. Questions, guys, anywhere? The derivative of sine is just positive cosine. So it's easy to mix that up. It's like it goes negative. So yeah, the negative was already there and it stays there. So you only have to use the quotient rule if you're using, if there's like variables in the numerator and the denominator when you're taking the derivative. Yeah, because like x over 6, that's really just 1/6 times x, you know, and if it was like 3 times x, you'd be like, oh, it's just 3.
It was 3x over like 2.
Yeah, if there was something else, yeah. Like down here was like x plus 5, then you'd have a lot more work to do. Don't do more work than you need to, though. Any other questions, guys? Okay, before we get to our quizzes, they did release the free response from your AP exam. I think some of you have looked at it already, so scrolling through it, it's very similar to what I gave as your practice free response problems, like very similar. So CalcMedic is a site that I like that has worked them out. I haven't worked them out for you guys yet, sorry. So this was the first one that dealt with this graph, gives you the domain and the points, and then the equation of the graph. This was on the calculator part, so then it was just finding the different pieces. So let's see. So if you're finding h of 3, remember that was the composition of those two functions. So you find f of 3 first, plug that value into g, and then that gives you, is that looking familiar to anyone? Yes, okay, good. And then where does this f of x function equal 1? Guys, that was just literally look at the graph and draw a horizontal line at 1. Where does it happen? Like, okay, don't overthink this. Well, I'm just saying, like, if you're like, okay, where does it equal what? Here, and here. Yeah, that's all. The hardest part on this was just making sure you kept track of which was f of x, which was g of x. So guys, you got those two. That's 2 points already. Okay. This one was asking you to solve for x. Like, when did the g of x function equal 2? So that's just a calculator problem. Like, you can do this algebraically. I would have just graphed the two and look where they intersected. I don't know what you guys did. And then the end behavior, I think, is what they were asking. Sorry, I don't have the question. G of x is an exponential function, but your base is less than 1, so it's going to approach that horizontal asymptote of 0. That's why this one is 0. And then the last part, it's not an inverse because x values are repeated. I mean, again, almost identical to the one you did in class, so that's helpful. Hopefully. Let's look at the other. Yay! Yeah, it's 3 and 4. 3 and 4. The non-calculator ones were hard. Well, 3 was a trig one, just like it looked just like the one I. Okay.
I know, it was throwing me off. I was trying to make sure
Oh yeah, guys, this was like your practice one too, where you're just setting up the equations. Let's see if I can pull up the solution again. So like they gave you these values of 0 and 91, and 0 gave you 40 and 91, like you're just plugging those numbers in, okay? You're not actually solving anything there. You're just like writing two equations if you needed a system. Then this you can solve with a system of equations. Did you guys get scared because it was natural logs, or did we persevere? You got scared? Okay. All right. You got A equals 40, right?
Oh yeah, that's right.
That is, yeah.
Maybe I did it right.
Yeah, did you say like 396? Okay, that's good. Yeah, this one was just plugging in, finding like the rate of change there. I don't remember what that one asked. Hold on. Oh yeah, just so finding it with average rate of change. You're just using slope to find it as if it's linear.
I wrote a whole paragraph of that because I didn't know what the answer.
Do you think you covered any of this, or no? Okay, you're just gonna give them a lot to read. Yeah. Okay.
I actually don't know if I just asked, so I don't know if it's correct.
That's okay. And guys, remember, like, I mean, of course, it's awesome if you get a 6 on one of the free responses, but you don't need like, oh, I didn't get 6s on all of them, I'm not going to get a 5. No, you saw very clearly that you do not need 6s on. You need to scrape out as many points as you can. If you're like, oh, I got like a 4 on that one, and I think I probably got a 2 on that one, and you're doing great, okay? Also remember the multiple choice is weighted twice as much as the free response. Did we feel good about multiple choice? Yes. Okay.
I like some calculators actually harder, but sometimes I think I do well, and then that's when I like do it.
You're like, oh, I know this. Oh, I was wrong.
I wish they would release like 2 scores, like your multiple choice and scores faster.
Yeah.
And then like,
I know. Yeah, it'd be nice if you could know your multiple choice now, just to like know where you are going into it.
also like use the break. Especially because it's like the day after 4th of July.
Yes. All right, guys, this was the modeling one. Ladies rolling a wheel down the road, I guess. But guys, doesn't this look just like the one we did? Like, it's so similar, okay? You'd probably get like 1 out of 2 instead of 2 out of 2 on that section. But that, when I scored it on yours, like A, B, C, and D, like A and D were grouped together as 1 point, and then B and C were grouped together as a 2nd point. So you can definitely get partial credit on that. And figuring out F through P, that was just using the values they gave you. Like the radius was 9, the maximum height it went up to was 18. So you've got your midline. So the lowest it goes is 0, which makes sense. It's rolling along the ground. It's not going to go below ground. Okay. And then those increments of the x values or the t values, that's just the time it took to go through each part. It took 2 seconds for a full cycle, so that's easy to split up. Hopefully those 2 parts went pretty well. Let's see. What did C even ask? Oh yeah, so the multiple choice and then the rate of change from T1 to TT, which is K. This is one part that you kind of just learned about with concavity, which is so weird that derivatives are not a part of their content, yet they ask a question about the rate of change and expect you to answer with concavity. It's sort of weird. If you just said it's decreasing on that interval, you've got a shot at the point. I'm not sure if they'll give it to you or not. But if you explained in a weird way, you probably won't get it. But if you were just like, it is decreasing, you might get your point there. Okay? I'm not sure how the readers are going to do that. And then the last one. So you've got your two functions. You were like, what? We're combining E and arcsine? What is happening? So part I, just setting it equal to 10 and then being able to solve that algebraically with your logs, natural logs. The arcsine part, you needed to remember the domain. Yeah, so you're just solving your equation there. And you're leaving it with a natural log in it. You're not expected to have like a singular value for that. Okay, so those were both just plugging it in and solving. Let's see. More functions. So B, letter I, that was just condensing, knowing your properties of logs. Hopefully, we know our properties.
Didn't simplify it all the way. Can we get Russian?
Like, what did you do?
I think I left it as 16x.
To the 7th over x to the 9th? I would think potentially. Because you did the directions of writing it as a single log. Like these, I mean, this is just a solution done by someone who works at Calcmetic. This isn't like AP Central putting out the solutions. Those don't come out till July. So this is their best guess at it. I kind of think anything along, oh, it won't let me write there. Anything that has condensed it to a single log. I feel like you've got, yeah. And then the next one, you're just doing a lot of simplifying with your trig values there, your trig properties. Like knowing 1 minus sine squared is cosine squared, recognizing secant 1 over cosine. Like that's just basic substitutions from when we did trig proofs. What do you think? Did you guys get here? Okay, good. That's when I'm like, oh yeah, you should know that. There are, every once in a while I'm like, it's tough, but that I'm like, oh, you know things. Let's see, what did C ask for? Okay, so you're setting it equal to 0. And then solving. That one I need to look at a little closer. Like I see what they're doing, but okay. Because let's look at what the directions said. It said. Yeah, because your domain would have been everything from -1 to 1. Yeah, I'll have to look at that one a little closer. That one is tricky. But overall, we feel like pretty okay. You scraped away some points, guys. Okay, good. And hopefully the multiple choice is good too. There's a chance. There's a good chance, guys. Okay. Let's do trig derivatives quizzes. I think this is the one I want to give you. Do you want to climb a mountain or strike and shield? Strike and shield. Strike and shield it is. Some of these you'll need, like scratch paper or whiteboard, but some of them are just basic. What's the derivative of cosine? What's the derivative of tangent? Okay, so just have your notes out while you guys are doing these.